You know, ionic compounds, they're held together by these incredibly strong bonds. So how on earth do you break them apart? Well, it turns out you can use electricity in a process we call electrolysis. Today, we're going to get to grips with the AQA required practical that shows you exactly how it's done.
Okay, so here's the plan. We'll kick things off with the key ideas. Then we'll walk through the practical itself. After that, we'll figure out how to predict what gets made, tackle some exam skills, and then wrap it all up with a super fast recap. Let's jump right in.
Right, first things first, before we even think about touching any equipment, we've got to get our heads around the basic ideas. These are the fundamentals you absolutely have to know.
So that's the big question, isn't it? How can a bit of electricity literally break a chemical compound apart? Well, it all comes down to charged particles.
And that process, that's what we call electrolysis. The stuff we're spitting up is called the electrolyte. But here's the key thing you've got to remember. For this to work, the ions inside that compound have to be free to move around. That's why it has to be a liquid, either melted down or dissolved in water. You can't just take a solid lump of salt and expect it to work. No way.
So, the electric current is passed through these two things called electrodes. And to remember which is which, just use the mnemonic panic. Positive anode, negative is cathode. The positive anode attracts the negative ions, which we call anions, and the negative cathode attracts the positive ions, or cations. It's as simple as that. Opposites attract. So what's actually happening at these electrodes? It's all about electrons moving around. And the absolute best way to remember this is with another mnemonic: oil rig. Oxidation is loss of electrons, and that happens at the anode. Reduction is gain of electrons, and that happens at the cathode. Easy. All right, that's the theory sorted. Now for the fun part. Let's see what this looks like in a real lab experiment. Okay, so this is the gear you're going to need. We've got a beaker to hold our electrolyte, in this case, copper 2 chloride solution. We've got 2 graphite electrodes, and we use graphite because it's inert, and inert is just a fancy way of saying they won't react with anything. And of course, you need a low voltage power supply to get the current flowing.
The actual method is really simple. You pour your solution into the beaker, pop in the electrodes, just make sure they don't touch, otherwise you'll short the circuit, which is not good. Then you connect all the wires, switch it on, and just watch what happens.
So, you flick the switch. What are you actually going to see? Well, over at the positive anode, you should see bubbles of gas fizzing away. And at the negative cathode, you'll start to see a sort of pinkish-brown solid coating the electrode. So we see stuff happening, but what is it? What are we actually making here?
And that question, well, it leads us perfectly into our next section: how to predict the products. Now, this can be the tricky bit, especially when you're using a solution, because the water itself can join the party and react too.
Okay, pay attention because this slide right here is basically the key to everything. It gives you the rules. Let's start with the negative cathode. You've got a competition between the metal ions, that's copper in our case, and the hydrogen ions from the water. And the rule is super simple. The least reactive one gets to react. Since copper is less reactive than hydrogen, we get copper metal. Now over at the positive anode, if you have halide ions, like the chloride ions we have, they always win. You'll get a halogen gas. If you didn't have any halides, then you just get oxygen gas from the water instead.
Now we can show what's happening with these things called half equations. At the cathode, it looks like this. The positive copper ion, Cu2+, gets pulled towards that negative electrode. When it gets there, it picks up 2 electrons. That's reduction, remember oil rig, gain of electrons, and it turns that copper ion into a plain old neutral copper atom, Cu. And that's the solid coating we see building up.
Okay, so we're predicting we've made copper and chlorine gas. We can see the copper, but how do we know for sure that gas is chlorine? Well, we need to do a chemical test, and these are the 3 big ones you have to know for your exam. The test for chlorine is pretty cool. It bleaches damp blue litmus paper, turning it white.
Okay, so we've got the theory and the practical down. Let's switch gears and talk about the exam, and how you can use all this to bag some serious marks.
Right, here are a few absolute must-knows for your exam. First, safety. Always talk about using a low voltage. And if you're making a nasty gas like chlorine, you have to say you do it in a fume cupboard. Oh, and a really common mistake people make is forgetting that solids don't work. Always state the electrolyte is molten or dissolved. And finally, be ready to label a diagram of the setup. They love asking that.
Let's look at a classic exam-style question. Notice they've changed the chemical here to copper 2 sulfate, but don't let that throw you. The rules are exactly the same. They want you to say what you'd see at the negative electrode and write the half equation for it.
So how do you make sure you get every single mark for this? First, you describe what you see. A pink-brown solid forms on the cathode. Then you explain why it happens. Copper is less reactive than hydrogen. And finally, you write out the balanced half equation. Cu2 plus 2 electrons goes to Cu. Do those three things and you've got a perfect answer.
Okay, deep breath. Let's do a super quick recap to make sure all of that has stuck in your brain.
First up, electrolysis uses electricity to split up ionic compounds. But remember, the ions have got to be free to move, so it must be a liquid.
Second, don't forget your electrodes. Panic. Positive anode, negative is cathode.
Third, remember where the electrons are going with OIL rig. Oxidation is loss, which happens at the anode, and reduction is gain, which happens at the cathode.
And finally, those all-important prediction rules. At the cathode, the least reactive positive ion wins. And at the anode, if there's a halide, it's going to win every time.
And just to leave you with something to think about, this isn't just some experiment you do in a classroom. Electrolysis is a huge industrial process. It's how we get really reactive metals like the aluminum for our phones and drink cans. It's how we make the chlorine that goes into bleach in swimming pools. It makes you wonder, doesn't it? Just look around you. How many things exist purely because of this one process?